Okay, dear participant, and good evening, all of you, and welcome back today. This is the 12th lecture on correlation and regression of our ongoing workshop on Python essential for data science. First of all, once again, good evening, everyone, and a very warm welcome to this session. I hope you are all doing well and are ready for yet another insightful and hands-on session. Today's topic is correlation and regression analysis, a fundamental area in statistical modeling and machine learning that allows us to understand a relationship between the variable and make informed prediction. So during this session, we will explore an introduction to the correlation and regression, including what they mean and why they matter. Okay, and applications in data science and research with real-world examples of how these techniques help solve problems. The key differences between correlation and regression, both conceptually and in terms of uses, the type of correlation with examples and visual interpretation, a gentle introduction to the regression analysis leading to practical modeling, how to perform multiple linear regression using Python, and finally, how to make prediction and evaluate a model using appropriate matrices. So whether you are working on academic research, industrial project, or building AI model, understanding correlation and regression is crucial for the turning raw data into actionable insight. So let's get started and dive into this powerful part of the data science toolkit. Okay. So here the content already have shared with you, and the file is there in your hand also. Okay. So now I am going to share the content which we will cover during the session. Okay. And here is the screen. And okay, this is the file which we will cover today. Okay, and everything what we need is inside in this file. So we are going to start this module 4.4, correlation and regression analysis, with the brief introduction about the correlation and regression and their applications. Then using the Python, we have to evaluate, we have to establish these results. We will fit the curve. Okay, then we will develop a model for prediction. So all these are inside in this file, and the content which we need to present here are ready. So the correlation and regression analysis are the fundamental statistical technique used to study relationship between variable. Correlation measure the strength and direction of the association between the two variables, and typically expressed by the correlation coefficient R, or we can use rho sign. So we know correlation coefficient always lies between -1 to 1. If the value is very close to or equal to -1, the relation is negative. And if it is very close to 1, positive 1, then the relation between the two variables is positive. And if the value lies between -1 to 0, okay, so as soon as this value will vary towards 0, the negative correlation will become low. Okay, and in the same way, if the value for positive, which lies between 0 to 1, so towards 1 will be high correlated, or towards 0 it will be less correlated. Okay, and if the value of R is equal to 0, in that case there will be no correlation. So the we will compute these values, and along with we will establish the heat map for the correlation. Okay, this will also we have discussed in the previous sessions, But today during this session also we will present the heat map or matrix of the correlations. Okay. And also then we have the correlation analysis. Here is the definition. Correlation measures the strength and direction of the linear relationship between the two quantities variable. Okay, quantitative variables. And the type of the correlation is also here discussed. Positive correlation, when one variable increase, the other also increase. Okay, in that case we have the positive correlation. And the negative correlation, when one variable increase, the other variable decrease. And zero correlation, no relationship between the variables. Okay. Then after we have the method which we can use to, and this is a very famous and very, I think all of you are very familiar about Pearson's correlation coefficient. And here the formula is R is equal to summation x minus x bar, y minus y bar upon under root summation x minus x bar square and summation y minus y bar square. Okay, where x bar and y bar both are the mean of the arrays x and y as well. So by using this formula, we can easily calculate the value of a coefficient, correlation coefficient. Okay, and here R range, the value of R must lie from -1 to +1. Okay, if R is greater than 0, this is the positive correlation. If less than 0, negative correlation. R equal to 0, no correlation. Okay, so from these values we can easily we can detect, we can observe which type of the correlation between the two variables are there. Okay, then after we have the Pearson's rank correlation and used for ordinary data or non-linear relate. Okay, so here is the formula. Spearman correlation coefficient rho is the rank-based measure that assess the monotonic relationship between the two variables. Unlike Pearson, Spearman correlation does not require a linear relationship or normally distributed data. Okay, so we have to observe the difference between these two. Okay, so here is the formula. R is equal to, you can see summation xi minus x bar yi minus y bar upon root and summation xi minus x bar square and summation y minus y yi minus y bar. Okay, and here are the description about xi and y are the data point. X bar and y bar are the mean of x and y respectively. And here the same interpretation is there. If R is equal to +1, the perfect positive correlation. If R is equal to -1, this is the perfect negative correlation. If R is equal to 0, then we don't have any correlation between the variables. Okay. And here is the regression analysis is also there. Okay. So regression model, the relation between dependent variable and one or more independent variable. So you know y is a function of the dependent or independent variable, independent variables. Okay, so independent variable can be one or more. According to that, we can establish the regression analysis. So according to the independent variables, we have the type of the regressions we can see here. First is a simple linear regression model. Okay, here only there will be two variables. Y is equal to beta naught plus beta 1, x and epsilon. So x is independent variable, y is dependent variable, beta 1. Beta 1 is the slope of the slope of the regression, okay? And beta 0 is the intercept. So here and epsilon is the error, small error, okay? Or you can say the error term. So used to predict y based on x. So when we have the values of x and according to that, we can predict the y value. So from this, by using this equation. And when we need to fit the curve, we need the values of beta 1 and beta 0. Then we can fit this linear regression. And for the multiple linear regression, you can see from this equation, y is equal to beta 0 plus beta 1 x1 plus beta 2 x2 and so on beta n xn plus epsilon. Okay, so this type of the you can see when y depend upon multiple variables like x1, x2, x3 and so on xn. Okay, where beta 0 will be the coefficient constant term and epsilon is some error. Okay, so beta 1, beta 2 and so on beta n have the same meaning as we do discuss in the above. So this will be useful when we have multiple variables independent. Okay, and y will depend upon x1, x2 and so on xn. So this is the multiple linear regression and first one was linear regression. So both are very highly useful and here are the applications which are very important to know here. Applications in data science and research. In economics, we can use for the predicting GDP based on inflation rate, and in medicine, analyze the effect of a drug on recovery time. In machine learning, models, feature selection, and predictive models, we can use regressions, and many models are there which are based on the regression. Okay, and in engineering, we can use for understanding the failure rate of the material based on stress. Okay, so here we have the simple example, and we will. Okay, here is the only comparison difference between correlation and regression. Don't worry about this code which you can reflect in the red color. Actually, this code is used to print the table inside this file. Okay, so by using this file, this code which you can see in the red color, this is just you can see at this place here. Key difference between correlation and regression. So in the first column, we have the features. In the second column, we have the correlation. And in the third, we have the regression. So from this place, we can easily compare the difference between the correlation and regression. So if we will see the definition, so measure the correlation, measure the strength and direction of a relationship between the two variable. And on the other hand, regression models the relationship between dependent and independent variable to make prediction. And purpose for correlation identifies whether two variables are related and how strongly. Okay, that will depend upon the values of the R which we calculate by using the given methods. And on the other hand, regression establishes a mathematical relationship to predict one variable based on the other variables. Okay, so by using the regression, we can establish a relationship between X and Y variable. Okay, so Y will be dependent on X variable, and X may be one variable or the multiple variable. So according to that, we can easily establish mathematical relationship which can be used for the prediction. Okay, and what are the causality of correlation? Does not imply causation and only measure association. And in the case of regression, can suggest causation if certain conditions are met. And then we have the, yes, directionality. No distinction between the dependent and independent variable. But in the case of regression, has clear distinction. One variable independent influence the other dependent variable. Okay, and equations in the case of Pearson correlation coefficient we need to calculate. Okay, and in the case of regression we have the linear equation, or you can see y is equal to beta 0 plus beta 1 x plus epsilon. Okay, and range of values in the case of correlation we have lies between -1 to 1. Okay, and we have discussed about the perfect positive, negative, no correlation. Okay, And in the case of regression, coefficient can take any value. When we have any regression equation is there, so based on independent values, we can choose any value to predict the value. Okay. And last one we have is the use case, used to measure the strength of the relationship between the two variable. Okay. So this will be based on the value of R. And on the other hand, we can use regression is used to predict the outcome based on the relationship between the variables. Okay, so these are the some little difference between correlation and regression, and both are highly useful in data analysis as well as in the machine learning models for prediction recommendations. Okay, and here then after we have the introduction of the correlation only, and here we will not go through more detail about this, we have discussed already. So here positive correlation, negative zero has been discussed. So let's come to the example. So here is the example and how we can calculate correlation. Okay, and very simple. First we need the two libraries. One library is numpy is np, and other we need to import is pandas is pd. So these two libraries are required. After that, we need data set. Okay, and here we are taking the sample data, height and weight of the individuals, and heights are 160. The heights are in centimeter. Okay, so 160, 165, 170, 175, 180, 185. These are the height, and weight are corresponding to all these. We have 55, 60, 65, 72, 78, 85. Okay, so we have two arrays. One is height and other is weight. So corresponding to these two variables, we will compute correlation by using Pearson. Okay. And the method you can see here is correlation using numpy. Okay. And here is the function np dot correlation coefficient, height and weight. Okay. Then after we will print the value, and also we are using here, you can see pandas. Okay. So both the libraries we are using here, numpy as well as pandas to calculate correlation. Okay. So here if you are using the pandas, and inside pandas you can see here we have to establish first data frame by using the pandas, and then after we will use this data frame to calculate. You can see here we are using df dot correlation. Okay, and method we are using Pearson. Okay, and df, this is the data frame, and this data frame involve both height as well as weight. Okay, and store inside df, and this will calculate the correlation using pandas, and then after we will use print function here, and when you will execute all these sequence of statement, how you can do, just press shift and enter. Okay, by using shift and enter, you can see, yes, you can see Pearson coefficient, the value is 0.9978. Okay, so this value is very close to 1. This value is very close to 1, but not equal to 1. Okay, so this is the this value represent positive correlation, or you can say highly positive or the perfect positive. Okay, perfect we can say only when this is value is equal to 1, but this is a little bit less than 1. And here you can see this matrix. You can see this is the matrix, correlation matrix. We can say this is the correlation matrix, and returned by pandas. And inside you can see here we have the two variables. Okay, height and weight, and both the variables you can see in the column. In the first column we have height, in the second column we have is the weight, and similarly these two variables are appeared in rows. Okay, and here in the row you can see first is height and then weight. And you will see that when suppose that we have x variable and y variable, so if you will correlate x variable with x, so this will be always perfect correlation. Okay, since all the values will match with each other. Okay, and same value is associated with the x as well as y, and the line when you will join, that will be the perfect line which will divide x and y axis at 45 degree. The slope in this case will be 45. Okay, and you can see here is height, and height is associated with height. The value is 1. You can see 1. And similarly, when we have is the weight, and here is also weight. Okay, the variables are same, and that's why here correlation is 1. Okay, so height with height, weight with weight will always be 1. And when we will correlate height with weight, height with weight, that is, you can see the value is about 0.997791. And similarly, here you can see weight with height, and the value is same as the above 0.997791. Okay, so here the correlation is positive. Okay, so this is the correlation matrix. So if you will have more than two variable, so this will always according to, if there are two variable, then 2 by 2 matrix. If there are three variable, then the matrix will be 3 by 3 order. If there are 10 variables, then the matrix will be of order 10 by 10 order when you are using pandas. Okay, and in the case of Pearson, we can have only this value. Now again, we have very interesting example, and examples are very quite simple. Just you need to use the syntax. Okay, and following the same, you can easily establish correlation, regression, and everything. We will discuss one by one, and how you can establish the regression model also will be there. Okay, so here we want to use compute correlation, compute Pearson correlation using sns.pairplot and df.correlation. Okay, so pairplot we have discussed in the previous lectures, and same we are using here, and in the more detail. Sorry. So here you can see we are using the tips data. Okay, and the tips data, you know, is available in seaborn library. Okay, and here also we are using the seaborn library for to calculate the correlation coefficient. Okay, and here the library import seaborn as SNS, pandas as PD, and import matplotlib.pyplot as PLT. Okay, and here we need to download the data set of tips, and which will be stored inside DF. Okay, and then after these are the same step which we have used in the previous lectures. Only we need to select the numerical values, since when you will we need to find out the correlation coefficient, so we need only the numerical values, not the other type of the data. Only when we have the numerical value, for that we can calculate correlation coefficient. Okay, so here we select the data type, see the function df.select underscore data type. So which type of the data we need to use at this place, and that we want to include only number. Okay, so inside this function you can see here we are using number. So number of each column will be selected automatically and stored inside numeric underscore df. So this will be the only we have numeric data. Then after we can use here for this data, we are using numeric underscore df, and we are using here correlation, and method is Pearson. Okay, so inside you can mention method, which method you want to use here. Okay, so here we are using Pearson correlation. Okay, and then after we add space visualize, display the correlation matrix, and here print, and this is the correlation matrix will be printed. And if we need the heat map, okay, we need heat map also, and here we are using plt.figure figure size 8 by 6, and by using the sns.heatmap, okay, so we with the help of sns library we can plot heat map, and here inside at this place we are using the correlation underscore matrix, which is calculated at this place. Okay, the values are computed at this place, but we visualize the same values which we are printing in the matrix form, and we can visualize in the heat map. Okay, and annotate we have is true, and CMap we have is cool form, and FMT format we are using float values 0.2f. Okay, and this is the title which we want to use for the graph correlation heat map of tips data, and plt dot show this will show the graph. Okay, so when we will press shift and enter. Yes. So actually data set is very heavy. That's why it will take some time. Okay. So here you can see this is the, see this one. So this is the correlation, Pearson correlation matrix. Okay. And there are three variables which contain numerical values. Okay. So on the top you can see we have the total bill, tip, and size. And also in the row, first row we have the total bill, second row we have the tip, and the third row we have is the size. Okay, so here you can see diagonal element. Each diagonal element have one value. Okay, so this will happen in each case, since x with x, y with y, z with z, these correlation will be always equal to 1. And when we compare total bill with the tip, and you can see the value is 0.675734, which is greater than 5. Okay, highly positive correlated. And similarly, you can see size with size also. This is value is also again more than 0.5. This is also high correlated positive. Okay, and similarly, you can see tips with the total bill, this value and this value are same. Okay, so whether you are correlated tip with the total bill or total bill with tip, the value will be same. Okay, and similarly you can check the other values of inside this matrix. Okay, and the same values which we print in the matrix can be seen in the heat map, and usually we can say correlation heat map of the tips dataset. Okay, so this is the correlation heat map. And on the left hand side in this graph, you can see there is a bar. Okay, this one. And the values on this bar will vary from minus, these values will lie between -1 to 1. So all the values inside this heat map you can see are greater than 0.5. The values which we compute here in the matrix, you can see all the values are greater than 0.5. Okay, so here there is no negative value in this matrix. So that's why the values are starting from 0.5 to 1, since all the values lies between in this range. Okay, so the color is also changing according the values are increased towards 1, and dark blue means near 0.5. Okay, and as soon as this will go up to towards 1, and when the value is 1, in that case that will be the dark blue, dark red, sorry. Okay, 1 means this red color means 1. So we can easily study this heat map, and diagonal box you can see. This is 1, this is 1, and this is 1. Okay, and the values which are very close to 0.5, is 0.49. You can see these are the dark blue, and this is the lightest blue. Okay, this is the light blue and this is the lightest blue. Okay, so this color means close to 0.7. Okay, if these values are not appeared inside this box, then also from the right hand bar, which you can see, we can judge, we can guess the uh, matrices from the site, which variable are more correlated, and their correlation effect we can see. Okay, so if there is any question related to this correlation which we discussed till now, you can unmute your mic. Okay, you are allowed to unmute your mic. Yes, if there is any question, you can ask from me. Yes, please. Okay, I think there is no question. Okay, I can check the chat box also. Yeah, no question. Okay, so here then after we are using Pearson and Spearman correlation, and these methods are also again very familiar. And correlation measures the strength and direction of the relationship between the two variables. The two most commonly used correlation coefficient are Pearson and Spearman correlation. Okay, so here you can see we are using scipy.state library. Okay, so inside we can have both the method. So import numpy as np, and from scipy.state import Pearson R and Spearman R. Okay, and then after we need some data set, and this is a sample data set you can see at space. Okay, this is the sample data x and y, and the values are 10, 20, 30, 40, 50 inside x sample data. Okay, and then we can have the Pearson correlation. You will use this function. Okay, Pearson x comma y. Okay, and here we will print the value, and then we will use the Spearman. Okay, here you will use the same Spearman R. So when you will execute, and yes, you can see the values by using both the method. Pearson correlation, the value is 0.993, but in the case of by using Spearman correlation, the value is 1. So this is the perfect correlation, and this is the highly positive, okay, correlation. So very close to 1, you can see the value is also by using Pearson very close to 1. Okay, so in this way you can use, but here is the example use of the pandas. Here is the example to use pandas, and for that we have to create the data frame, and then after we can use. So here you can see if you are using Pearson correlation. Okay, so here you have to mention like in this way, Pearson underscore correlation df dot, since the data frame we have is df, and here you have to mention the method, which method you want to use. Okay, method is equal to Pearson, and this statement is used to print the value. Similarly, by using the for correlation, we have to mention at its place method name, and method is Spearman. Okay, and then after we will use the statement to print the value. Again, quite simple, shift and enter. Okay, so by using the pandas, okay, pandas is always very, you can say, always turn the values in the form of a matrix. So here by using the Pearson correlation, you can see the matrix of the correlation with the x and y variable. Okay, x will be always equal to 1. So diagonal element in this matrix you can see 1. And the other correlation value x with y and y with x. these are 0.992543. Okay, so this is also again the highly correlated. And if you are using the Spearman, and you can see this matrix, all the values are equal to 1. All the values are equal to 1. Okay, so here also we try to present here the key difference. What is the key difference by using these two methods? Okay, Pearson is best when data has a linear relationship, and Spearman is better for non-linear monotonic trend. Okay, so according to these difference, we have to choose which method is more suitable according to our data set. Okay, don't actually we have the data and we are directly use without thinking, but you have to keep mind these key difference. Okay, and according to that, you have to choose the method which will be more appropriate and will return the suitable result. And according to that, when you will choose, then the models which you will establish will be more, you can say, accurate and return the best values. Okay, so here we have again talking about the introduction to the regression analysis. So this is the part of the correlation, and now we will focus on regression analysis. This is very useful. Okay, and also by using the methods which are we are using here, or we will discuss, we will establish the linear regression model, or multiple linear regression, or we can have the non-linear also. Okay, so here what is regression analysis? Regression analysis is a statistical technique used to model the relationship between dependent variable and one or more independent variable. Okay, so by using this technique, we can establish the relationship between the dependent and independent variables. Okay, and that will be the mathematical model. And by using that mathematical model, we can use for understanding relationship between the variable. We can predict future values, and we can identify the key influencing factors. Okay, and here are the some types of the regression. Okay, so here these are the types of regression analysis which we can use. And first one is the linear regression, and this is the model. The relationship is a straight line. Y is equal to mx plus c. There will be the only two variable, and m is the slope, c is some intercept on y axis. Okay, and then we have the multiple regression. Basically, we have discussed this part in the beginning, but still we are recapitulating the same. Multiple regression extends the linear regression with the multiple independent variable. In the linear case, we have only one independent variable, but in the case of multiple regression, one will be the dependent variable and multiple independent variable. Okay, and then we have the polynomial regression, fits polynomial curve for non-linear relationship. Then we have the logistic regression, that this will be used to classify or classification problems for binary outcomes. Okay, then we have the ridge and lasso regression. This will be regularized technique to prevent overfitting. Okay, and last one we have is the non-linear regression, models complex relationship that are not linear. Okay, so these are the some types of the regression analysis, and mostly we are talking during this session linear, non-linear regression. Okay, and yes, all these, and one we can discuss also about polynomial regression. If there is any example we have chosen to present here. Okay, otherwise that example can be in the tomorrow's session. So here we have the simple linear regression with Python. And the equation you can see y is equal to beta 0 plus beta 1 x plus epsilon. Epsilon is the error part. Beta 0 is the intercept on y-axis. Beta 1 is the slope of the line. Okay. X and y are the y is dependent variable and x is the independent variable, and beta 0, beta 1 and epsilon error term. Okay. So here is the see. These are the libraries which are required for this linear regression. And first we need to import here numpy as np and matplotlib dot pyplot as plt to visualize our data. Okay. And next is the we are using here linear regression that will be, and also you can see here the scikit-learn. Okay. This is the one type of the machine learning model. Scikit-learn dot linear model. Okay, and this is the model based on machine learning. Import from this library, we will import linear regression. Okay, so here you can see we have is the data set. We are taking x is equal to np array and 1, 2, 3, 4, 5 reshape minus 1 to 1. And then we have the you can say y, and the values are 2, 4, 5, 4, 5. Okay, these are the dependent variable, and x is the independent. Okay, so here we are creating the create and train the model. So here we are choosing the model first. The model which we are using is linear regression, this model. Okay, and now the steps which are we are using at this place. Note all these one by one. And when you will train your model or any kind of the machine learning model, which we will discuss in the tomorrow in the more detail. Okay, but here is the just like a very simple model is chosen to fit only the linear regression and how we can use. So then after choosing the, we need to fit the model. Okay, we need to fit the model. And here you can see model.fit x, comma, y. Okay, so according to these variable which we are using here, we will fit the model. Then after fitting the model, we have the prediction. Okay, since linear regression is used to predict the value. Okay, so here also we are using this is the y prediction based on x. Okay, so here model dot predict x. Okay, so x will be known, and which is the independent value corresponding to that we will predict y value. And then here we will plot two graphs are there. One is scatter plot. One is the scatter plot. Okay, which will be the actual data. Which will be actual data. And by using this actual data, we will train the model, and then after we will plot the model. And here you can see this is the plt.plot x comma y predict, which will be based on this trained model. Okay, and this will automatically fit the regression line. Okay, and color we are using red, line width we have is 2, and label is regression line, and here label we are using actual data. Okay, and on the then we have the, you can say x label and y label, then legend and plt dot show. Okay, we have the x label is independent variable, y label is dependent variable, legend is also there since we have two graphs are there, and plt dot title, a simple linear regression, and then after we are using plt.show. So when we will shift and enter. Yes. So here you can see the blue color. Blue color is the actual data which is inside this graph. So here our data in the blue color, you can see about this line. Some values are on the above and some values are below. Okay. And based on this actual data, and by using the model, we have the regression line in the red color. Okay. And also when you will scroll down, the value of beta 0. Okay, what do you mean by the beta 0? This is the intercept, the value which will intersect on y-axis, that is about 2.2. Okay, when you will increase this line at this point, this will intersect, and that is the value of beta 0, which is 2.2, and the beta 1. Beta 1 is the slope of this line. Okay, so this line is inclined about, the value of slope is 0.6. Okay, this is the slope. Okay, and the slope is calculated by using the inclination of this line, like m is equal to tangent theta. Okay, so if you want to calculate the value of theta, so this is the value of m, and the equation we have is m is equal to tangent theta, and theta will be equal to tangent inverse m. So by using this equation, you can calculate the degree, also angle, but here the slope is 0.6. Okay, so to fit the curve for the linear model, we need these two values. So the required values are also computed at space by using this linear model. Okay. So then after you can say, using the stats model for detailed output, we can have, yes. So here we are using the stats model. We are using here stats model dot API is SM, and import warnings also we are using here, so that when we will execute, why we are using warning simplifier. Okay, to ignore the warnings, since the libraries in Python, or just like when we are using the seaborn or the other libraries, these are regularly updates, and due to the update there is some warning, and if you want to ignore these warnings, then we have to use this library warning, and you will use here warnings dot simplifier action ignore categories user warning. Okay, so by using this statement, all the user warnings will be removed. Okay, so here when we will execute, here is add constant for intercept, and xsm is equal to sm dot add constant, and x is the same which we calculate in the above. Okay, we take the x array, and here we are using the train model OLS. Okay, so here model is equal to sm dot OLS y comma x, since y is independent and will depend upon this value. Okay, and then this will print model dot summary when we will execute. Yes. So here inside the values which are OLS regression, okay, what you can observe, read these values, check these values from yourself. Okay, and what are these? So from these values, we can easily observe that there is two variables, one is x and other is y. So from this table, we can see that dependent variable is y. Okay. And model which is used at space is OLS. Method is least square. Okay. And date, this is the today's date, 3rd July, when we execute this model. Here is the time also. You can see about 8 6. Okay. And number of observations. So this is the all about the detail. Residuals you can see 3, and the model is 1, and covariance type non-burst R squared. This is important. The value of R squared, adjunctive R squared, and F static is 4.5. Then probability F static is 0.124. Okay, then log likelihood is minus 5.25. Okay, then these are the other values. So what you can see from this table, so the model summary, this is returning the model summary which we used at this place. Okay, so R squared, you can see this value, which is 0.6. The meaning is that 60% of the variability in the dependent variable y is explained by the independent variable x. This suggests that the moderate model fit. Okay. And then we can see adjusted R squared. This is the adjusted R squared value, next value. Okay. This is the adjusted R square, which is 0.467, slightly lower due to the small sample size. Only 5 observations are there. It can be adjusted for the number of predators. If we can increase the number of the observations, okay, we can adjust this value. Okay. And F static, you can see, which is 4.5. And then we have the probability of F static, which is 0.124. Okay, so these are the p values. And yesterday we discussed about the p values. When p value is greater than 0.5, value of 0.05. Okay, alpha. So and here also we can observe that the p value is greater than 0.05. Okay, so from these values, we can see that the overall model is not statistical significant at the 0.05 level. Okay, meaning we do not have the strong evidence that the model explains a significant portion of the variance in Y. Okay, so these are the interpretation which we need to discuss here, and how actually whenever we have the large data set, only then we can have more accurate. But here we have only the 5 observations. Okay, and when we will compare the p-value, from that we can study that how much our model is accurate. So here, according to the p-value, which is 0.124, the overall model is not statistical significant. Okay, and if you want to see some more, like the key observations from this overall, and some values are there also. Scroll down here. Okay, here you can see the constant, coefficient. Okay, and standard error. At this place you can see standard error. These are the t values. Okay, these are the t values, and these values are for the constant. Okay, here is 0.101. This is the p value for constant, and then you can see the other values and see for the x1. Okay, 0.6. Then error is 0.23, which is high. Okay, standard error, and you can see here is a 2 point, sorry, this is a 0.23 and the p value is 0.124. You can see the p value is 0.124. Okay, and here also we need required Durbin Watson. The value is 2.017. Okay, and then we have the Jarkabera 0.570, probability 0.752. Okay, so from overall these values, what are the key observation? The sample size is very small. We have n is equal to 5. This limited statistical power and reliability. Model note statistical significant p-values for the f-test and coefficient. We can't confidently say that x1 predict y. Okay, according to p-values. Since the p-value is greater than 0.05 significant level. R squared is moderate. Despite insignificance, the model explains 60% of the variance, which could improve with more data. Okay, actually, we should have more than 90% for more accurate. And Durbin Watson value, which you can see here, which is 2.017, suggests no serious autocorrelation in the residual. Okay, actually, this value must be equal to 2 at least. Ideal is equal to 2, but here we have 2.017. So this value is also such that no serious autocorrelation. So this is the interpretation about all these return. When you will check the model, how is it fit and how much is more accurate values for the prediction. Okay, so this type of the test are also required whenever you need or you want to fit any model. Okay, so testing and the accuracy play very important role. How much accurate is our model, which you are establishing for the prediction or the recommendation or machine, which are based on the machine learning models. Okay, so this type of study is highly required. Now we can have the example for multiple regression with Python. Okay, and this is again very simple. And I tried to explain everything in this example, which are the libraries which are required for this multilinear regression model. Okay, and in the multilinear regression is the extension of the simple linear regression, where we have the multiple independent variable predicting a dependent variable. Okay, so here see carefully what are the required libraries. Before discussing this one, if there is any question from your side, please, you can ask from me. You can unmute your mic. Any question? Dear participant, if you have any question, please, you can unmute your mic. I think I feel that only I am speaking here, one side. And I allowed you to unmute your mic. Okay, whenever it is required or needed, you can unmute your mic, put your question, and if there will be discussion from both sides, this will be more interactive. No question? Okay. There are two options. When we teach in the class, I always ask it to the student. And when I don't get any response from the student, then at last we have one option to say to the student, okay, either you are more intelligent and you catch everything which I present during this session, or all the things which I present cross overhead. Okay. So what I think or I about you, first option. Thank you. Here is the screen. Okay, and these are the content. So we are talking about the multiple regression, which is the extension of the linear regression. Okay, and again, this is very quite easy and interesting. So these are the required libraries for this model. Okay, and all these you are already familiar. Then we have from scikit-learn model to underscore selection import train test separate. Okay, so to train the model we have to split the data, and on the basis our selected data we will train our model. Then we will test it, then we will predict. Okay, so here this function is used to split the dataset into training and testing set, and it is commonly used in the machine learning to evaluate model performance. So whenever you will train the model, this step is always there. So corresponding to each line, I try to explain here so that whenever you will get this file and you will go through, this will help you. And then next we have is the scikit-learn.linear underscore model import linear regression. Okay. And then after we can have, you can go through the detail about this, a class that implement ordinary least square regression, and it fit a linear model to training data and predict continuous values. And then after we can have the next library, and here you can see from the scikit-learn dot matrix import mean underscore squared error and R2 square. Okay, so here at this place we have the two functions. These functions evaluate the performance of the regression model. Mean squared error measures the average square difference between actual and the predicted value. Okay, and here we first we need to execute this sequence of the statement. Okay, so here we are executing by using shift and enter. Okay, then after we need to generate the data. Okay, so here you can see creating the data set. Here np.random.seed42, and then we have the x1. We are taking randomly, okay, 10 to 100, 20. Okay, this is the independent one variable. Then this is the independent two variable. Okay, so 10 to 20, these values are 10 to 20 and is divided into 100 point. Similarly, these are this is the okay, and 10 to 100 and 20 points are there. Then we have 20 to 200, 20 points are there. Okay, two variables are there, x1 and x2. So here this is the y. You can see y depend upon this curve. You can see 5 plus 2 product x1 plus 3 x2 plus np, and this is the error random dot normal. Okay, this is the dependent variable with some noise. Some noise means error. Error, this is the error term. Okay, so then after on the basis of these statements, we will create the data frame. Okay, and this is the statement. df is equal to pd dot data frame x1. We have x1, x2. We will take x2, and for the key y, we have y. Okay, so this will create data frame. And if you want to print the head So what we do, we have to run this statement. Okay. So here these are the head of the data set x1, x2, and y. And first five, when you will use this head, first five values will be there. So these are the index 0, 1, 2, 3, 4. And this is the x1 variable, then we have x2, and these are the y. Okay, so these values will be generated. So now then after perform multiple regression, okay, and for that we have to separate the data into training and testing. This is the second part. Okay, so x will be, we have df x1 comma x2. This is the independent variable, and this is the y is equal to df dependent variable. Okay, so we have to split the data set here. So x all the independent variables, whether these are the 2 or 3 or more than 3. Okay, so all the independent variables will store inside x, and this is the dependent variable y. So when you need to test and train, okay, so here is the x train and this is the y train. Okay, this is the x test and this is the y test. All testing and training both will go simultaneously by using train underscore test underscore split. Okay, so here we have the x, then y variable, and test size we are choosing here 0.2. We can increase, we can change this value, and random state we are taking at base 42. Okay, then after we create and train the model. So model we are taking at a base linear regression. Okay, then after we will fit the model dot fit which x train and y train. The values will be taken from this place, x train and y train. So by taking these values, we will fit the model at space. Then after model coefficients, we will calculate, and these statement will print the intercept and coefficient value. So when we will execute shift and enter. Yes. So here you can see this is the intercept value. And these are the coefficient. We have two variable. One is x1 and other is x2. So the value, the coefficient of x1 we have is this value, and that of y, that of x2 we have is this value, and this is the y-intercept. Okay, these are the coefficient which you can see. So this is the value of beta 0, this is beta 1, this is beta 2. Okay, now then after we prediction and model evaluation. So predict on the test data. Okay, so we will use here this function model dot predict x test. Okay, so x test we have to use here, and corresponding to this we have the y predict. Then we will evaluate the model. Okay, for that we are using mean squared error, y test, y predict, and R2 squared, y test, y predict. Okay, so both the value we are using here, and this will compute both the values. Okay, MSE and R2. Then we need to execute shift and enter. So here you can see the mean squared error is 163.58 and R squared error is 0.99. Both are very high. Both are very high. Visualization of the prediction. So here we will plot the values, which is again quite simple. SNS scattered, x equal to y test, y is equal to y predict, plt dot x label, plt dot y label, plt title, and show, then shift and enter. And see inside in this graph. Okay. So these are the actual versus predicted value. Okay. So here the blue color is only for here only we have one graph. Okay. So on the horizontal line, we have the actual values. We have actual values. And on the vertical line, you can have the predicted values. And corresponding to this, we have actual versus predicted values, which are uh, highlighted in this graph. Okay, according to our result. So here, these are the some key point. Multiple regression model relationship with the multiple predator we are using here, and R square indicate better model fit, and feature selection is crucial to avoid overfitting. Okay, so here we don't have actually the model is not more accurate according to these values. Okay, so mean square difference must be as small as possible. Okay, so here the values are very large. So here we are using the applying regression analysis in the Python, and we have the we can use regression in finance, healthcare, marketing, engineering to make predictions and understand relationship between the variable. Okay, so here is the insight about the libraries which are required here. So all these are the same which we do in the previous one. So first we need to execute. Okay, not required. And then we have the at this place real data set. Load real world data set. Okay, from this place, this will be very useful and we can have more insight and understandable. So the above steps which we do and the same we have to follow here also. Okay, so here this library is required. We are fetching California housing data set. Okay, and load the data set. So this is the data set and we'll store inside df and we will take the price df price housing target. Okay, so this is the target value we are using here and it displays the first row. So when you will execute shift and enter. Yes, so these are the some few rows of the data set and you can see the variables which are inside this data set taken from cloud-based dataset. Okay, so in the first column we have the med inclusive and house age, average room, average bedroom population, average occupation, latitude, longitude, price. Okay, so corresponding to all these parameters having the numerical values are at this place. Okay, so we can observe the data set. Then we can go to for EDA, exploratory data analysis. Okay, this is a part of the since when we are going to establish a model. Okay, so the statistical part, cleaning the data set, which type of the data is there, all these steps are required to fit any prediction model. Okay, so here we are using the describe function. This will return the summary of the static, and by using this statement we can have the heat map also. Okay, so we are using two functions here. One is describe and other we have is the heat map. Heat map is used for correlation. Okay, so this is again very quite simple. Just enter shift and enter. Yes. So here this is the summary about the data set which is inside our which we download, and main in the count you can see these are the count of each variable, which are 20,640 each. Okay, no missing value in each variable. Then you can in the second row find the mean, then we have the standard deviation, then we have the minimum value in each variable. Okay, then first quartile, second quartile, third quartile, and maximum value. So all these information can help us to understand the data set. Okay, and these are the some also the other for the other variable information. Okay, so from this summary, we can easily stand the maximum value, minimum value corresponding to each variable. We can check if there is no any null shell, okay, empty shell, and we can see the count of each variable is the same. The meaning is that there is no all the variables have same number of rows. Okay, and first quartile mean, and also this will help us to understand the data set as well as maximum value and minimum value corresponding to each variable. And then after we have the feature correlation. So from this place we can easily understand which variable is more positive correlated, negative correlated, okay, and no correlation. So according to that we can establish our model. Okay, so here you can see, we can see here on the horizontal line we have a price, longitude, latitude, average occupation, population, average bedroom, average rooms, average age, and medicine वगैरह. Okay, and these variable are on the left side also. Okay, starting from price, longitude, latitude. So as we discussed here, the most negative will be dark blue, and most positive will be in the red color. Okay, and other values which varies according to you can see the bar on the right hand side. Okay, so here you can see the highest dark, except x with x, y with y. Okay, you can see the highest value is 0.85. Okay, 0.85 is the positive. So you can see average bedroom, and then you can scroll down. Okay, so average bedroom and these two are highly correlated. Okay, average room and average bedroom. Then you can see here is the minus 0.92. This is the most negative value. Okay, see the longitude, and here is I have to scroll down. Yeah, this value. Okay, latitude and longitude. These are the highly negative correlated. Okay, so from this heat map we can easily observe which are positive correlated, which are negative correlated, and which values are very less, which will be very close to zero. Just like you can see here 0.013 or minus 0.0049. Okay, so these are highly very close to zero. So there is very less correlation between these variables when you will compare. Okay, so then we can define feature and target value. So here you can see here we have to define the target value and feature values. So here we are choosing these three feature values: average room, average occupation, and med inclusive. Okay, and y is price. Okay, so this is the target value, and this value will depend upon these features. Okay, so features are these are the independent variable, and y is dependent variable, which is the target value, and these are the features. Okay, so two values are required. Then after you can see this statement is the same as we do in the previous model. Okay, x train, x test, y train, y test, then train underscore test separate. So the data set for the training we need 80%, and for the test we need 20%. Okay, so this will do automatically by using this one. So here test size we are taking 0.2. 0.2 means 20%. Okay, test size, and other for the training this will be 20%. We can manipulate this value. We can take 10%, we can take 5%, we can 20%. So according to that we can choose. So we need to execute this shell. Okay, it has been executed. Now we need to train the regression model. And this is again same step which we do in the above. Create and train the model. Model is equal to linear regression, and then model to dot fit x train y train, and then model parameters we need to calculate here. Execute this statement. Okay, here intercept is 0.6081, and coefficients you can see here we have the three variable. Three features are there. Okay, so these are the coefficient 0.4368, then minus 0.404, and minus 0.0038 something. Okay, so according to the variables which we choose, these are the coefficient for this model. Then the next step we have is the make prediction and evaluate, and the same step are there. Okay, y prediction model dot predict x test and evaluate model performance, MSE mean squared error, y test, y prediction, and R2 will be equal to R2 underscore square, y test, y prediction. Okay, so always these two methods will be required whenever you need to do evaluate model performance. Okay, and then you will print the values and execute, shift and enter. So here you can see the mean squared is 0.70 and R square is 0.47. When you need to check, okay, how much is this is accurate. Okay, analysis part is also required. Okay, just 1 minute. One minute, please. So here the mean squared error which is 0.70. Okay, and average square difference between the predicted and actual values. The lower MSE indicate better predictive accuracy, but here MSE is 0.70, which means on average the model prediction deviate from the true value by square root 0.70, which is 0.84 approximately. Okay, so the model prediction are not far off, but there room for the improvement. Okay, so according to this value, which is 0.70, we can say that the model is not perfect or the accurate. We can improve this model by using some technique. And how we can improve this will be discussed in tomorrow. Okay, and R square difference is 0.47. Okay, this indicates that 47% of the variance in the dependent variable, and dependent variable y is explained by the model, and it aligns closely to the R squared or LS output. The model capture moderate variance in the data, and the remaining 53% is unexplained, possibly due to omitted variables, noise, or the small data size. So this is the interpretation about these values. And to improve, we need some increasing the data set, include more, we have to include some more predictive features, and we can validate the model on the test data. Okay. So all these, how we can improve this data set, this model, we will discuss in the coming tomorrow session. Okay. So if you need to visualize the predictions, we can do here. This is the last step here. Shift and enter. Okay, so fit size, X test, Y test, and when you will visualize, and you can see in this image, on the horizontal we have the actual price, and on the vertical line we have the predicted price. Okay, so this is look like in this way. Okay, so we can have the more improvement in this model is required. So this is all about the model, how you can use all these by using the machine learning model, and we can predict. But here, according to this model, we need some more improvement for this regression model. Okay. So dear participant, this is all about the today's session. And if you have any question, you can ask from me. Now the session is open for discussion.
Hello, sir.
Haji, hello.
Sir, that model is there, uh, plot is there of points. So how can we interpret that, sir?
Just a minute. I have to share the screen. Okay. So here, by seeing this image, you can see on the horizontal line, you can see that the from this data set, if we have the more positive curve. Okay, when we if you want, if you will correlate actual price and predicted price. Okay, see the scatter values. These are not more positive correlated. Okay, in that case, we have like in this diagonally. But here, you can see the graph is like if you will fit this data set, which you can see here, this will be like this one. But if this is more closely to the diagonal of this image, like from this corner to this corner, that will be more correlated. And if we have the more correlated, okay, then we can say these are more accurate. And also by seeing this value, okay, this value shows that less correlated. Mean squared, we have to observe the mean squared error. This mean squared error is the difference between the actual and the predicted value. Okay, so we to improve this prediction, we have to reduce the error between actual and the prediction. Okay, so the difference between actual data set and the predicted data set, if the difference is large, okay, then we have less accurate. The difference is less, as much less, okay, as we can do. So we have more accuracy. So for that, we always reduce to this value, mean squared error and R square. According to that, we can have the whether the prediction is accurate or not. Okay, and from these values, and the same is you can see here inside the image. So from the image, when you will observe that the correlation curve, when you will fit this curve, okay, on the basis of this data set. Okay, so we need highly more you can say highly positive correlated, and that can be possible only if the value you can say when the correlation is 1. Correlation is 1. And this can be possible only if the slope is equal to 1. Slope is 1. Okay. So if there is slope is 0, actually the slope positive or negative. What is the meaning of correlation? If the values are inclined from like in this diagonal. Okay, in this image, you can see there are two types of the diagonals are there. One is this corner to this corner. Okay, so when we have this square and it doesn't have 45-degree, okay, and this can be possible if we will join this diagonal with this diagonal. Okay, and in that case we have m is equal to 1. Okay, tangent 45 value is 1. And if you will have like in this way, this is the join this point, this corner to this corner. Okay, like in this way. So this is the -1, negative. Okay, tangent minus 45. Okay, so highly positive, highly correlated when we have value is 1. Okay, correlation is 1. And when is -1, then we have in this direction. And when we have 0, then no correlation when the line is horizontal. So horizontal line will always reflect no correlation when slope is 0. Okay, so we must have some correlation between x and y. But here, when you will observe that the predicted and actual data set, we have very less correlated this image. So that's why we have to improve this one. And we can easily do, we can improve by using some, to add some more features inside the model, which can be possible in this model we don't add, but the model which we will present in the coming session tomorrow and the next we have 2 days or more. Okay, and we will present very nice models and not only this regression, but we have some more models which I try to introduce here for any type of the analysis like risk analysis or the prediction model, recommendation model, which will be based on the machine learning. And there are so many models we can use depending upon the data set. And the most important thing when we develop or the establish any kind of a model, testing is required. How much accuracy of the prediction or the recommendation is there? Okay, so in this model which we present here, you have just an idea how we can use the machine learning models and all these things which we discuss for the regression model, for the prediction. Tomorrow also we have to follow the same steps. Okay, and look like a similar type of the working we are doing, but many things we have to add some. Okay, so when you will go through all these steps, so that tomorrow session will be very beneficial, very useful for you, and how you can integrate the other models which are existing. And when we are using multiple model, we can compare each other to check which model is more accurate and which model we choose to for the accuracy and which model will be perfect for our data set. Okay, so many things we have to observe when we want to establish any kind of the model like machine learning model, prediction model, recommendation model, and other models, okay, which are highly useful in health science, environmental models, and for agriculture, for business, and many more. Okay, but the common thing is the steps which we are discussing here, along with some more steps we have to introduce. Okay, so any more question, please?
Thank you, sir.
Hello, sir.
Hello, good morning.
Good
Good morning.
afternoon,
Acha, good afternoon. Okay, good
Yes,
afternoon.
yes, sir. Good afternoon, sir.
How are you?
Yes, sir. Uh, Fine, sir.
Great.
How's your weather there? So, sir, the simple question I want to ask is it possible to transform a 2D image to 3D image in Python?
Sorry, I don't get your question.
Okay, when you have a graph or a map that is in 2D form, maybe in another software, is it possible to convert it to 3D using Python?
Okay, using Python 3-dimensional plot.
Yes, 3 dimension. Yes, sir.
Yes, we can do, but the thing is not much accurate according we do in the MATLAB. Okay, we can plot 3D images in Python also, and but less accurate. Okay, so
Okay.
if you need how you can plot a 3D image, see, I am sharing my screen again. Okay, so what you will do, yes, and then after just 1 minute, okay, yes, here I am taking collab. I am using collab, okay, and collab is inside my Google Drive, and my G drive is here. And then I have to go my drive, and inside my drive there is a collab. Just 1 minute, I
Yeah, we're
have.
getting.
Please wait.
Yeah, lecture. Okay,
Just 1 minute.
okay. Okay.
Okay, and here algebra. Okay, I am taking this file. Okay, demo.ipl. So here you can see generate with AI. What you will do here, give me example to plot 3D, or you can write here 3D plot. Okay, so when you will enter, yes, so here is the prompt. You can see here is the prompt. You can see how you can plot 3D image. Okay, this is the data set. You can see these libraries are required. Okay, but here the data set is randomly taken. So this library is required, mpl underscore toolkit dot mplot 3D import access 3D. Then matplotlib dot pyplot splt is also required, and this library is required to generate random data. Okay, and these are the statement. So here this is the plt dot figure. Then here we have the subplot. Okay, 111 projection 3D. Okay, these are the X, Y, and Z. Okay, so X is one array, 10 point will be there, Y will be there also randomly point, and in the range 10, Z also we have the array, there will be 10 points, okay, 10 values will be there, and all these values will be generated randomly uniform. Okay, so X, Y, Z have these variable we have, and in other sense you can say the length of each variable must be equal. Okay, values will be different, but length must be equal. then this is the statement. This statement is used for scatter plot. X comma y comma z say is equal to r, marker is 0. Okay, and then you can set the X label, Y label, Z label, and PLT show, and then shift and enter. When you will run this code, and in the beginning this will connected, okay, and then we are able to show here. Yes, you can see this is the 3 plot. This is the 3D plot. You can see this is the 3D plot for data. Okay. Yes. Here you can see the X label, Y label, Z label. So in this way, if you have the data set and you want to visualize inside 3D, you can do in this way.
Okay.
Okay. And the other way, if you have any data which you can put here inside, and then you can use the statement. Just like you can take here X variable, then Y variable, and Z variable. And you have to store the values at this place, then ask this generative AI help me to plot the graph. Since many times if you don't have the, actually why I am taking the help from this generative AI, since all of you have many times many questions, many problems are there, and you are not able to visualize or some other type of the questions if you have, so you can put your question at this place and you can get some basic information. You can get the prompt means which type of the statement are required to visualize or for the other type of the like computing is required. So everything you can take help from Google Cloud, and you can easily use it for visualization or the interpretation or other type of the help which is required. You can put your question at the place and you can get some information to help you. So this also will help you to for your question, your prompts. You can easily use for any kind of the task which you need to for your data analysis. Okay, so that's why Google Colab is very helpful. Sometimes when doing some experiment, if you have the challenge, you can take help from this side. Any
Okay,
more
sir.
question?
Thank you, sir.
Okay. Any more question, please? Other participant, Mandeep Kaur from Punjab. Are you from Punjab? Suhair Al.
Yes, sir. Good evening. Suhair Mahati.
Very good evening. Good evening. How are you?
Fine, thank you. How are you, sir?
So how about the today's session? Got some insight?
Yes, it was beneficial for me. A long time I did not do any statistic or graphs, yani. So it's a great reminder for me. Yes, thank you so much.
Okay. Pooja Arora madam. Dr. Pooja Arora ma'am. Dr. Navneet Kaur. Vivek. Sonali Panda. Toshika Lata ma'am. Any question, please? Okay, no question. Faisal Ali Khan. Okay. So thank you all. No question, no question. Okay. So dear participants, this is all about the today's session. And once again, thank you to all to listen me very carefully. Okay. We are left only 2 sessions. So tomorrow we will discuss some machine learning model, and that will very helpful to all the participants how you can establish by using the technique which we discuss for the regression model. Okay, so I will try tomorrow there we can be able to present only one model, since when we are talking and we establish any model, so at least 2 to 3 hours are required. And on the last day, I request to all the participants to present, because in the last day only simple model will be there. Okay, and validity function will be there. So I requested to all the participants put your feedback regarding all the sessions, as well as the content which we present during these 12 14 days workshop. Okay, and your suggestions are very important for us to improve the quality and how we can make more interactive. And any suggestion which you will suggest, and for the coming workshop or the faculty programs. Okay, so your feedback is very, very important for us. So feedback form will be there, but you have to put your feedback also, open your webcam and unmute your mic. So live feedback, if you will give us, that is more important. Okay, and on the basis of this feedback form, you will get your certificate, and also the last questionnaire will be there, which you have to complete, and we will provide by tomorrow after the session. Okay, so before the last session, you will complete so that you can get your certificate on the last day of the session. Okay, so once again, thank you to all, and now time is over. Good night and stay connected, and do practice on the content. File already available with you. Okay, good night. Now it is time